Hi, my name is Savin, and in today's talk, I'm going to talk about my experience building data science infrastructure for well over a decade now, and some of the work that we have done very recently within the Kubernetes community. As part of this talk, we also have a quick demo that my collaborator, Bala from Intuit, will be handling. If you guys are interested, you can also follow along this demo within your own browser as well. We'll be sharing a handy link to access the demo too. Now, for those of you in the room who are either practicing data scientists or have built data science infrastructure in the past or currently as well, this might be a familiar narrative. But just imagine, like let's say your organization wants to build a recommendation system. So you have a data scientist who is tasked with that job, and the first thing that they would like to do is maybe perhaps spin up an ID instance on the cloud, so maybe a Jupyter notebook on AWS, or maybe it's sort of like some ID PyCharm on their local workstation, their laptop. And the very first activity that they want to do right after this is get access to some data so that they can start making sense of that data. Maybe your data is stored in some Snowflake data warehouse, some Databricks, data lake. Maybe you have sort of like, stitched together your own data platform on top of S3. But there's usually sort of like some mechanism that's needed for this data scientist to now sort of like understand what data is available, what is the quality of that data, how to access that data so that all the security and data governance concerns are addressed, and how to quickly and efficiently access that data so you're not waiting for like minutes and hours to get access to that, so that you can start playing with that data. You can start sort of like, building an intuition around it. But then as soon as you've sort of like, crossed this first hurdle, you're presented with the next one. It could very well be the case that the kind of data analysis that you want to do or the kind of models that you want to train, that's not possible on your local workstation, not possible maybe perhaps on the notebook instance that you have in the cloud. Maybe you're doing some feature engineering step that requires huge amount of memory that's just not available on your laptop. Maybe you're training a model that requires GPU. Maybe you decided that maybe you want to train a model for every single country that your service operates in. So you suddenly need to train 200 odd models. And if you have hyperparameters as well, that number can sort of like grow rather quickly. And then there's sort of like, comes this question that, okay, how do we handle this large scale compute? It's likely, given that we are at KubeCon as well, that your organization may have already invested in some Kubernetes clusters. And then the first question comes is that, okay, how do you give access to this data scientist to these Kubernetes clusters? Now, of course, this data scientist, very technically sophisticated, but in data science, not necessarily in software engineering. Now, is there an expectation that they'll sort of like suddenly become a wizard in the concepts of Kubernetes and understand how to sort of like launch these large scale workloads really efficiently? Is that really sort of like, what they should be doing day in and day out? Now, let's assume somehow magically they are able to sort of like, breach that barrier as well. Then, now we have this data scientist who is able to sort of like access this data, not only locally, but also on the Kubernetes cluster. They have somehow been able to figure out a story around like how to ship their code to the cluster, how to ship their dependencies, library dependencies, data dependencies, and whatnot to that cluster. If there are some errors that have crept up, if jobs are failing for whatever reason, maybe perhaps they have some mechanism, some solution to sort of like, figure that out as well. The next question comes is, how do we sort of like productionize this work, right? Up until now, the data scientists are still sort of like actively iterating through a bunch of hypotheses. So they need to sort of like now run this model training workflow on top of some kind of workflow orchestrator. It's likely that the data engineers in the organization have already made a decision that maybe, like they went with Airflow, or, if they are sort of like a Kubernetes native shop, then they may have already sort of like invested in Argo workflows, and they may have some data engineering workflows running. And now what the data scientist really wants to happen is that his or her data or like machine learning workflow should execute right after the upstream data engineering workflows have executed. And now there comes sort of like, the next big barrier is the expectation that now somebody is going to sort of like take all of the work that the data scientist has done and rewrite it or re-implement it in the SDK that many of these workflow orchestrators expose. And then once you sort of like, have that, the story doesn't really sort of like stop there. You'll have many, many different versions of these workflows. People will, or your data scientist will want to try with different algorithms, different features, different hyperparameters. Maybe they are sort of like new data scientists on the team who want to sort of like try out different set of experiments. So many versions that are running either concurrently or over a longer period of time. And you need to sort of like, really make sense of like what's really happening around that. There's also sort of like this big question in machine learning about trust. Can you actually sort of like replicate the results that you have seen in the past? Because if you can't do that, then it's really difficult to trust the model that has been shipped. So this question of reproducibility also becomes really important, which is closely coupled with the story of versioning as well, that it's not only just important to sort of like keep track of what has really happened, but it's also really important to sort of like ensure that any past state can be reliably sort of like built up again. Now, we have, let's say, a bunch of different models that are being trained. The next big step comes, how do we sort of like deploy this model? Now, depending on your business context, model deployment could mean many different things. You may want to sort of like deploy the model within a cell phone device, or maybe it's a microservice that has really high expectations on SLA. If let's say it's Netflix's recommendation systems, then the kind of SLAs that are established around that microservice, they are like really stringent. On the other end of the spectrum, you may have this model servicing an internal dashboard where the QPS may not be as high. If the service goes down for a few minutes or even a few hours, nothing will sort of like break. So that could be an entirely different pattern as well. Another common scenario is where people sort of like just generate a bunch of scores offline, they do some analysis, write a memo, share it with the execs, that can sort of like influence a business decision. So on the deployment side of the house, there are many, many different ways to deploy any sort of like given machine learning model that sort of like can be sort of like quite specific to the business case at hand. And then, only at the top of the stack, we sort of like now start to worry about the actual modeling. What is the kind of data that we are dealing with? Is it tabular data, or is it sort of like, unstructured data? What kind of algorithms do we need to use and whatnot? And if you look at it, any machine learning project within any organization, independent of the state of its maturity, has to sort of like deal with these stacks, right? Like you need to sort of like understand how are you accessing your data, how that data is stored. You need to understand where that compute is happening, even if it's happening locally on your laptop. What is the story around workflow orchestration? Have you already invested in a workflow orchestrator? Do you want to sort of like make a new investment? How are you thinking about sort of like, many of these concerns that these days are lumped into sort of like this word MLOps around sort of like versioning, reproducibility, experimentation management, and so on and so forth. And then, of course, like how do you actually make use of that model? How do you make sense of that? How do you sort of like rinse and repeat and iterate on that entire machine learning process? And then at the top end of the stack, the concerns around like, okay, what is the actual machine learning problem? How are you taking that business problem and going all the way and translating that into a mathematical model? And this was basically sort of like my team's charter at Netflix, where sort of like, many of these learnings came from. And our goal was that, we had sort of like a really large data science team that numbered upwards of 300. And our goal was that, okay, how do we sort of like make these talented folks productive so that they're not sort of like spending a bulk of their time fighting with infrastructure? I mean, of course, like if they wanted to be experts in Kubernetes, then they would have chosen to be engineers. But then they really sort of like the craft of data science, and we need to sort of like meet them where they are. And one of the biggest hypotheses that we had was that the problem that we were sort of like, staring at was this of productivity. If you look at any organization, they have an immense desire to invest in machine learning. There's a lot of data that's being collected. All these organizations, they are sort of like very keen to sort of like embed machine learning, embed intelligence into a variety of business problems. And then at the same time, there are many technical advancements that are also being made, both on the machine learning side as well as on sort of like, raw compute infrastructure side of the house as well. Every single day we are sort of like, seeing sort of like the specs that sort of like public cloud can offer, sort of like, increasing the advancements on the machine learning side as well, newer kinds of models that are sort of like coming up. But then the big problem is that these sort of like two curves, they haven't intersected yet. And the reason is not really lack of desire, but it's sort of like just lack of productivity. And that needs to be bridged by any kind of MLOps tool that exists out there in the market. And then the other sort of like learning here was if we sort of like look at the stack and look at sort of like the order of concerns from a software engineering point of view, from a builder point of view, from our point of view, it's bottom heavy. We need to sort of like make a lot of investments on the data side of the house, on the compute stack, on the orchestration stack. But then if you look at it from the topmost stack, that's where the data scientist really wants to exercise a strong degree of autonomy. They really do care what kind of training framework they are using, how they want to sort of like build the model, what kind of features they want to use. Most data scientists, they don't really have explicit opinions around how the data is stored, whether they are using Kubernetes for large-scale compute, what kind of workflow orchestrator they are using, as long as those concerns are well satisfied. And that's where we started this project called Metaflow at Netflix, which we open sourced in December 2019 at AWS reInvent. If you're interested in Metaflow, very recently we also launched this sandbox where you can sort of like, without having to install anything, you can go to this URL and you can sort of like play with Metaflow, and the entire infrastructure is backed by a Kubernetes cluster and an Argo workflow instance, so you can sort of like try out all the promises that we make in our documentation. Now, very simply, what Metaflow enables is a programming model that keeps DAGs front, right, and center. So defining a DAG is very simple and straightforward. So you can use some Python decorators. So in this case, the step decorator to denote nodes in your graph, and then the self.next invocations to denote the edges in your graph. And then you can execute this as you would execute any other Python file. And then Metaflow will go ahead and execute this, and you can sort of like have a bunch of different patterns, including sort of like branches, for eaches, and whatnot. There are a lot of primitives that Metaflow comes with. So of course, like on the data side of the house, it ships with a high throughput S3 client that provides you higher throughput than what's possible with a local disk attached to your instance. So you can get like upwards of 25 Gbps of throughput very easily using Metaflow. And then this also sort of like ties into your internal data layers as well as whatever primitives you have for data catalog, so that data discovery becomes rather simple and straightforward. And then everything gets versioned by default. So every single time you execute any Metaflow flow, a unique run ID is generated. The entire internal state is versioned in perpetuity for you, so that I can go back and I can ask that, hey, Bala executed this workflow 6 months ago. Can I see sort of like what was the internal state? What was the model that was generated? What were the internal attributes that were generated? Not only that, can I sort of like actually go in and resume Bala's workflow from whatever arbitrary step that I want to? And that sort of like allows people to build on top of each other's work very simple. Now, we are at KubeCon, so we definitely need to talk about Kubernetes, and that's where it sort of like comes in. Now, imagine, like you're a data scientist and you want to sort of like, let's say, train a model over a list of hyperparameters that is sort of like 100 long. With Metaflow, you can sort of like drop in this decorator at resources, and let's say, in this example, I specified memory as 128 gigs. You could very easily also specify GPUs, CPUs, and whatnot. And what Metaflow will do is it will execute your start step locally on your laptop. It will execute the train step, 100 instances of that on Kubernetes, so it will generate 100 pods, and it will run those steps. And it will also pipe all the logs back to your local workstation. So to the end user, it would seem that like somebody came in and just added a whole bunch of RAM to your laptop and went away. And that sort of like makes it quite trivial for people to sort of like scale out their workflows in a very Pythonic manner. And then, of course, like once, let's say, the user is happy with what they have, then it could be the case that, they want to sort of like integrate their work with their favorite workflow orchestrator. That could be Airflow, that could be Argo workflows, step functions, like a whole bunch of options that are available out there. Now, the good thing is that all of these workflow orchestrators, they execute a DAG. With Metaflow, you've already written a DAG, so we can sort of like compile down this workflow into something that these workflow orchestrators can easily understand. And at that point, you basically get the best of both worlds. So this workflow would be sort of like a native Argo workflow template as well as a native Metaflow flow. You can imagine, let's say, for whatever reason, let's say this workflow fails, then because of the fact that Metaflow is capturing all of the internal state, you can actually go back to your laptop and you can resume your compute from wherever it failed locally. And you can sort of like iterate on it, you can fix that bug, and then you can again push it back to Argo workflows, and then your compute will resume from there. And that sort of like allows people to not really be an expert in Kubernetes or Argo workflow SDK while still sort of like enjoying all the great benefits that these tried and tested tools provide. Oops. There are a bunch of other functionalities as well that Metaflow provides that are sort of like, more geared towards larger scale teams. There are like functionalities around like how do you generate visual reports as part of every execution? How do you sort of like manage larger projects? How do you sort of like, think about dependency management and so on and so forth? Given that we are short on time and we want to sort of like give a quick demo, so I'll sort of like skip on that. Now, the one sort of like message that I want to sort of like leave you with before sort of like we start off the demo is that at the end of the day, for any organization to be successful in sort of like introducing any kind of intelligence into their applications, they need infrastructure that can sort of like go end to end, provide solutions to the entire life cycle of machine learning. That was basically our agenda at Netflix as well, which is basically what we have tried to build with Metaflow. So if projects of this nature sort of like interest you, excite you, I highly recommend going to this URL and giving sort of like Metaflow a try. But now I'll sort of like pass it on to Bala for a quick demo.
Hey everyone, I'm going to demo the Metaflow and Argo workflow side. So mainly I'm going to focus on the 3 areas. One is like a very simple Metaflow application, how you can develop and run it. And the second one, like how you can run your Metaflow application at scale using a Kubernetes. The third one, like how you can debug back your production issue on your local. So I'm using the same sandbox, the Metaflow playground. So if you see that it's a hello flow, I have like a start function, which is calling the eat function next, and end function. It has like a 3 functions. If I click the run current flow, which will run on the local as a Python application, and you can see the nice outputs are coming like all the logs. So starting, eating, and ending. And this sandbox is already having like a card decorator so that you can see the easily output of your flow. The next thing I like to go with like a DAG. So basically my start function is going to call like a 2 parallel steps, eat and drink, and join with the join step. Let's run. These all are like a simple flows, so you can able to run it in the local. So you can see that the eat and the drink was parallelly ran here. And one more thing, like every run, the Metaflow will give like a unique run ID for every flow, so that in future you can, if you want to refer it back or you want to resume it back, you can use this run ID for that Metaflow. So you can see the nice DAG is printed in the right-hand side. So given the time, I'm going to skip like a 3 and 4, which is like a artifact and versioning. The second one is like a parallel processing. I'm going to show that like how you can run your Metaflow application at scale. So in the Metaflow application, I have like a 3 steps, like a process, memory hog, and join. Mainly like a memory hog needed like more memory to process that, but I cannot run it on my local. So I want like some remote system like a Kubernetes or cloud, somewhere we need to run it. So Metaflow will support default like a Kubernetes if you want to test it. And here, before going to that, I'm having like the array of data. I want to run like these 3 steps for every element in that array. Like if you have like a list of hyperparameters, then if you want to train that model for each hyperparameter, you can have like a for each one. So let me turn on that Kubernetes one, because I don't have that much memory on my local, because every step need like a 8 gig memory, and I have like almost like 5 elements. So if I enable that Kubernetes decorator, then which will run on local, but it will submit that. It will submit the Kubernetes job on the remote cluster, but orchestration will happen on your local laptop. So you can see that it's submitting that all the Kubernetes job, and it's trying to create a container for every step. Give us a little bit time, so the cluster is scaling up. So you can see that all the jobs are completing and picking up the next process, which need like 8 gig RAM for every step. Okay. So assume that now you have a production application ready and you tested with Kubernetes job and you are ready to push it to the production. So to pushing to the production, you need like a production grade like workflow orchestration engine, which will need to give like a high fault tolerance and make sure like your application is running properly. So in that one, you cannot only rely on like a Kubernetes job. You need like a very well like a workflow orchestration engine. There only that Argo workflow is coming. Whoever doesn't know that Argo workflow is like a production grade open source container native workflow orchestration engine, which will run like a high parallel jobs on the Kubernetes. So to convert into that Argo workflow, the data scientists no need to learn about that all the YAML files and Kubernetes. The Metaflow will automatically convert your application into that Argo workflow template and submit it for you. To that, just you can give like Argo workflow create, which will create like a workflow template on a Argo workflow. Then you can just call trigger, which will submit that Argo workflow on your Kubernetes cluster. And Argo workflow is having like a nice UI. So you can see that the Argo, you can see that your application is start running as Argo workflow. It may take like a little bit time, so given the time, I'm like to show that the previous run, which I had that. So you can see that the Argo workflow was nicely orchestrated your all the steps with all the parameters in the array. It will create like a 5 parallel tasks, and it's executed like a process and memory hog, and it's joined back to the join step. If you see that all your resource quotas will be already configured in the pod. Suppose if you are declaring for 8 gig, it will automatically configure in your pod resource quota. And if you see that in the Argo workflow UI, you can see that a lot of options are coming like in the running UI. So you can see that you can suspend it, the Argo workflow when it's running, and you can resume it back where it stopped. Then another one thing, like suppose if you want to completely stop it, you can go out and stop. Stop will be like a graceful shutdown, and a terminate will be like a hard kill, like it will kill that immediately all the pod from the Kubernetes. Then you can get like a nice logs for that Argo workflow. Whatever your steps running, like you can click that log, then it will print like all your logs. Okay. Let's go back to things. Okay, so now you have like application ready in the production, but you don't want every time submit manually. You want to schedule it and run it. So there is a decorator Metaflow is providing like you can have like a at schedule, which will basically converting to that Argo workflow cron workflow. The Argo workflow is already supporting like a cron workflow. So when you have like this decorator and calling like Argo workflow create, Metaflow will automatically convert your application into that cron workflow in Argo workflow. Then it will run it every hour. So you can see that here there is another tab called cron workflow. You can see that which is created now, and it will going to run like every 1 hour. So in this case, suppose, hey, I want to run your application on demand. I don't want to wait for 1 hour. I just want to quickly retrain my models. So just you can submit it here, which will again trigger the workflow on demand. So third area I'm going to cover, like suppose if you have like a bug, how you can debug it easily in the local. So I'm going to create a bug, like divisible by 0, and submit it as a Argo workflow. And I'm going to trigger it. Just will kill my previous one. So you can see that just the submitted one is running, but it has a bug on the start step. It should fail. So technically, if you have any production issue, you need to log into the production cluster, go to that each pod and finding like what went wrong, all the things. But machine learning engineers, they don't have like any Kubernetes knowledge, and they will feel like, okay, now it's failed. So if that machine learning engineer want to debug it back in the local, so what they just need to do that, just they can call that resume. Equal to, because the Metaflow is keep tracking like all your run, so you can just give your run ID, then it will run it on your local, where that the workflow was left in that Kubernetes cluster. So you can see that it's failed in the local also. So the engineer can directly go and fix it and run it on the local with the given data to make sure it is working fine. Then he can push it back the fix into the production. So now he's going to make sure like whether the fix is working fine. Basically, if you want to learn more about like Argo product, please stop by that Intuit booth and Argo booth. In Intuit, we are using like a heavily that Argo workflow in the model training side. We are running like a 5,000 plus concurrent pod for training that models. So the Argo workflow will be scaled like 5,000 to 10,000 pods concurrently, and it will able to manage it. So now the application is fixed and it's run properly. Then user can again create. That means here create means you are pushing the fixed code into the production. Then again you can go ahead and trigger it. That's end of my demo.
Thanks, Pada. So Metaflow, what it provides you is a solution for different layers of the stack. And of course, what we demoed today was our integrations with Kubernetes. And that sandbox environment, by the way, was running on AWS, but now Metaflow supports all three major public clouds as well as on-prem deployments. For your data storage, you can use S3, Azure Blob Store, GCS, or you can sort of like connect with your Snowflake warehouses or Databricks Delta Lake. For compute, of course, Kubernetes is an option. We do also sort of like provide first-class integrations with AWS Batch. On the orchestration side of the house, the first integration that we started out with was Step Functions, which is a managed orchestrator that AWS provides. Very recently, earlier this year, we integrated with Argo Workflows, and we'll be releasing an integration with Airflow very soon as well. On the orchestration front, another sort of like interesting piece of work that's coming out very soon in collaboration with the Argo Workflow community is the integration with Argo Events, where you can essentially sort of like have these event-driven workflows. You can imagine sort of like, let's say in your data infrastructure, let's say there's some mechanism through which some new partition appears for some data set. then that can sort of like trigger an Argo event that can automatically trigger your machine learning workflows. And that can sort of like also come in handy for retraining steps of your pipeline. And of course, Metaflow automatically provides sort of like version control outside of any sort of like GitOps workflows that you might have. And then thanks to sort of like strong notion of artifact management, you get sort of like experimentation management out of the box. There's a UI that it ships with that we couldn't sort of like show you today. But yeah, if these things are useful, please do join our community. If you have any questions, any feedback, open to your questions. Thank you. Yes, please. So the question was, do we have integrations with the on-prem cloud? So basically, you can use any S3 compatible storage and bring any CNCF compliant Kubernetes distribution with that, and that'll work.
And for the GPU resource, right?
Yes.
Just like specify as memory.
Yeah, so the question was that, okay, how does Metaflow handle GPUs? So just like we had memory equals 8,000, you can have GPU equals 1, GPU equals 2.
Okay.
And then Metaflow will essentially launch the pod appropriately on a GPU instance.
Okay, thank you.
Thank you. Yes, please.
Hello, great presentation. In your example, you had mentioned that you weren't able to run it locally because it required 8 gigs of RAM. And then when it failed, did you say that it ran locally?
So basically, the step that required 8 gigs of RAM, that ran on the Kubernetes cluster as a Kubernetes pod.
I see.
Because the local instance that's running that VS Code instance, that has roughly 4 gigs of RAM, so that will fail. And then not only we need sort of like 8 gigs of RAM, we were running 5 concurrent steps, so we'll need 8 times 5, 40 gigs of RAM, which is not available in at least sort of like a normal laptop.
Okay, so in the debugging case, that case didn't require the extra memory, and so therefore you're able to debug it locally versus debugging in the logs.
Yeah, so the debugging step that we had, so let's say, you had a workflow that failed on Argo workflows, so you could resume that from any arbitrary step, and you can resume while it's running on Kubernetes as well. So the resume doesn't have to happen entirely locally. It can still sort of like happen on Kubernetes. Any more questions?
Well, thank you, guys.
All right, thank you.